You need to find the value of f for this set of triangles, and then find the area of a circle with radius 5 meters and find the circumference of a circle with radius 5 meters. I'll give you 3 minutes. Try it on your own. Then we'll go over it. They'll be here, I'm sure. By 8:15, we'll have, I'm sure, everyone but like 2 people. There's another one right now. Let's see who it is. You trust me. Told you. Yeah, I'm out of pencils, Cameron. You might see if a neighbor can help you out. Jacob was got pencils. Oh, there's 2 pens right there. Howdy. Welcome back. I said welcome back. How you doing? You great? That's good. That's what I like to hear. Morning. All right. Oops, there's another. Okay, today should be, theoretically speaking, I think the lecture take half the hour and then you have half the hour to work. That's the goal. We'll see how well we hit that goal. We want to find the value of f. In order to do this, we will need to set up either a proportion, blank over blank equals blank over blank, or find the scale factor. I'm going to try setting up the proportion, and then you tell me what I did wrong. F over 21 equals 6 over 15. That proportion is not correct. Cole, what do you think is wrong with that proportion? One of these numbers is not right. No, that one's okay.
15.
The 6 is not right. All right, if we look, F is this really big side right here, right? Over 21, which is the small side right here. 6 is supposed to be this really big side, not just this little part up here. So that should really be not 6, but 21. Oh, is it 21 too?
Yeah.
Oh, that's interesting, little queaky deek. All right, let me update attendance before I forget. All right. In which case, now that we have the proportion written, what do? Brock, what do you think? Now that we got it written, what do? Heck yeah, you cross multiply. So we'll get 15F. Why am I using my mouse? Equals 21 times 21. What is 21 times 21? Oh, that's all right. 441. All right, and then to get F by itself, we got one more step. We'll divide by 15. Which means F is 29.4. All right, so again, the real thing you need to watch out for the quiz this Friday is when you are setting up your proportion, you are paying attention to which sides you're using and which ones they correspond with. So if you do big over small, you need to do big over small, not the little part over 15. Does that make sense? Yeah, that makes sense. How could it not? I said it. I got the badge on, everything. All right. Okay. Find the area and circumference of a circle. So the area of a circle is pi r squared. Sounds like area to me. And if you need the circumference, just use pi d or 2 pi r. This was on your homework for 5.6. It's also on your homework for 5.7. So if you struggled with this question, those are the formulas you need. And then you just plug in 5 for r. So the area would be pi times 5 squared, which I think, let's see. If you type in Google calculator, I'll put that back up in a second. Do they have a pi? Yeah, they have a pi button. So you could use this pi button right here and do pi times 5 to the second power. If you want to use 3.14, you can, but your answer will be less accurate than the actual pi key because pi is an infinitely non-repeating decimal, not just 3.14. So we get 78.5. So that's about 78.5 meters squared. The other answer I would accept is if you don't reach for a calculator and you just leave it in terms of pi, you could tell me that that is 25 pi meters squared. Either answer is okay. Yeah. I would just use the pi key. I mean, if you draw, or instead of writing the Greek letter, you just drew a little pi. Is that what you're saying?
No, I said write pi, like.
Oh, PIE.
Yeah. Instead of drawing the pi. Like,
that would be fine, but you got to just do PI.
Yeah.
I'll take PI instead of the little thing. But the little thing is so much fun to write. Yeah. Look at this. Woo. Because you draw 2 lines and it's like, woo, they're having fun. You do a little squiggly. It's like a little party happening. All right, and then we do times 5. So again, you could just tell me that that is 10 pi meters. Or if you want to use your little calculator, 10 times pi is 31.4. Hey, that's what we thought of. Notice that for the circumference, we use meters, but for the area, you do meters squared. Because here you have 5 meters squared. Here you just have 5 meters, no squared. So here you got a squared. There you don't got a squared. And again, that is what you'll do for the homework. I think it was number 2 on 5.6 and I think it's also number 2 on the one we're going to do today. We'll talk about dilations. So we'll focus on learning how to do 2 things: how to identify dilations, construct dilations, and then use dilations in proportion problems. Really, to be honest, we already know how to do that second one. We care more about these first 2: identifying and constructing dilations. So a dilation is a transformation. However, it is not an isometry or a rigid motion. So unlike translating, reflecting, and rotating, a dilation will transform your shape and actually make it into something that's not congruent. And that's because it will make your new shape a different size from the original. It'll still be the same shape. All the angles will be the same, but it'll be either bigger or smaller. The definition is listed here. This is your definition. And again, it's more complicated than you would probably like, but that's because we have to avoid all synonyms. We can't use shrink, enlarge, bigger, smaller, any of those. What a dilation will do is it will take a point. If it's not on the point you're dilating on, then it will create a new point P prime by multiplying this distance CP by a scale factor K. Where again, put this in a box. This is probably the most important thing that's on your guided notes right now. This will be tested on. The scale factor of any dilation is the distance from C to P prime divided by C to P, which is just your new over old. New length over old length. Let me write that. New length divided by old length. Can we appreciate how centered I made those freehand? Like, do you see how old length is like almost perfectly centered in the middle of new length? It's not like to the left or right at all. I did that freehand. Freehand. All right. If P is on C, then it wouldn't move. Then P equals P prime. So if your point P is actually on the center of dilation, then when you dilate it, it won't get any bigger or smaller. This is probably the second most important thing that you will have in your notes. You might circle, put this in a box, star it. Let me draw some stars freehand. I'm pretty quick at drawing stars. If your K value is a decimal between 0 and 1, then the dilation is a reduction. It'll shrink it, which should make sense, right? If you scale it by a half, it will become a half as big. If you scale it by a third, it'll be a third as big. So if your K value is greater than 1, then the dilation will be an enlargement. So if you scale it by 2, it'll be twice as big. If you scale it by 2.5, it'll be 2.5 times as big. Scale it by 5, it'll be 5 times as big. What's the scale factor is your new length divided by your old length? No. That if it's between 0 and 1, so it's like a decimal or a fraction, like a half or a quarter or a third or 0.25, right? If it's less than 1, but it has to be a positive number, so greater than 0, then it will reduce it. It'll shrink it. It'll make it smaller. Does that make sense? Yeah, all right, good question. Okay, does everyone have these things boxed like they should be? And I've drawn an appropriate number of stars. Drake, do you have an appropriate number of stars on your page? You don't have any stars? You should put a star. What do you mean, why? It's like, why breathe? Why drink coffee? Why have cake on a birthday? What do you mean, why? All right, does anybody need more time to circle star and that kind of stuff? Okay, so these are the two type of problems that you're going to be asked to do. The first we'll do is the identifying. So this gives us a dilation that's already happened, and we need to identify the type, enlargement or reduction, and find the scale factor. As of warning, I'm about to, after I do this, I'm going to show you some to do, and then I'm going to, give you time to do it and call on people randomly. So this is how you're going to do that activity. The first thing that you have to do, actually, in my opinion, is find the scale factor. So again, scale factor is your new over old. For A, the new image is this one in red. I know that it's the new image because it has the apostrophes. Also, they were kind enough to draw this little arrow. That arrow will almost never be there. The new length from my center of dilation C to my new triangle is 3. The old length back to the blue triangle is 6. So then my scale factor is 3 divided by 6, or 1/2. Because a half is less than 1, this is a reduction. Also, you can see it in the picture, it got smaller. Yay? Again, most people will either get this or the exact opposite answer. And it really just comes down to, are you being careful about what the new length is and the old length? So like for this one, again, you have to, the first thing you got to do is just identify what's the starting, what's the ending. This is the starting triangle. The red one is the ending. And I know that because of the apostrophes. The new length from C to my red triangle is 5. The old length is 2. So then my scale factor, again, is new divided by old. 5 divided by 2, which is 2.5. And then we could say, since 2.5 is greater than 1, this dilation is an enlargement. Can I move this? Oh yeah, I can. Oh, look at that. Look at that. Move it up here. Yeah, there. Okay, easy peasy lemon squeezy. Questions, concerns? I think we're about halfway through this lecture. What do we got left? We're gonna have you try one, and then we'll do constructions, example, guide practice, and then done. Yeah, you should definitely have half the hour to work. The constructions does take some time, but I think as long as you pay attention for that part, you'll be fine. It's just really just using slope. All right, does anybody need more time to write? Okay, then it is your turn. Identify the dilation and find its scale factor for each one. And again, by identify the dilation, what we mean is tell me, is it an enlargement or reduction? That's what it means by that. All right, I'll give you 3 minutes. And then I think we might do a homework one. Yeah, let's do one homework. You already got it. Yes, and yes. Great, great work. You got one. You got one. You got one. You do one. There you go. It's going. Yeah. New number divided by the full number. So that's great. You have to look at the one with the apostrophe is the big one. That's it. All right, you got about 45 seconds left. You should use this time to check your answer to the neighbor or me, or I call on 2 people. What did I just do? All right, let's go over these. Well, that's nobody. 2, 6. Is that somebody? Miracle. All right, Miracle. First thing we want to do is find the scale factor, which is defined as your new length divided by your old length. For A, which of these numbers, the 2 or the 3, is the new length? That's right. Yep, because this one has the apostrophe. This is your new number, which means this is our old. So then our scale factor is 2 divided by 3. So is this an enlargement or reduction? It's a reduction. The triangle got smaller. Thanks, Miracle. All right, and then for problem B, let's go with Brock, I feel like you might be the most called up person in this class. You're just a lucky guy. All right, which of these is my new number? The 2 or the 1? Yeah, that's right. That's the new. Means the 1 is the old number. So that our scale factor is what? 2 divided by 1? That's just 2. So is this enlargement or reduction? Enlargement. Very good. It became twice as big. Okay, that's the first thing from this section that'll be on your quiz is those type of problems. Second type of problems are a little bit more difficult. In order to actually do a dilation, you will do one of 2 methods, and we're really just going to learn one of these methods. The first is you would use a ruler. So you'd actually measure the old distance, multiply that by your scale factor, and then measure that on your ruler. If you plan to get into architecture or really any painting or sketching or that kind of stuff, where they draw those like lines, that happens a lot to get perspective. I think that's what those are called, perspective images, where they have the little thing, you know, the lines, bunch of lines. I think it's a second semester thing in most art classes. You'll use this. What we're going to focus on is how to use it on a grid, because I don't want to get my rulers back out. So to do that, you're really just going to use slope. You will find the rise and run from the center of your dilation to the point that you want to dilate. You will then multiply the rise and run by your scale factor K, and then you will plot your dew point using the dew rise and run. Make sure at the end that you label your points. You'll lose half a point on the quiz and test if you don't put that apostrophe. You've already seen from the examples we've done how important it is to know which is the new and which is the old drawing. Does anybody need time to write this? Should be all printed out for you. Okay, then let us do it. So let's say that we have this triangle, ABC. We want to dilate it using the origin 0, 0 by a scale factor of 2. So how I'm going to do that, I'm going to draw this out. You probably don't have to draw it out. You could just do it in your head. But to get to A, I have a rise of 2 and a run of 1. To get my dew point A, then I'm going to multiply both of those numbers by my scale factor. So this would become 4. And this would become 2. So now, instead of going 2 up, 1 over, I'm going to go 4 up, 2 over. Does that make sense? Do you see how we did that? Again, I drew all this out, but you really probably don't have to. For point C, C is 4 to the right and 4 up. So if you multiply both of those by 2, my dew point C will be 8 over and 8 up. It's 8. It's 8 times by 2 times by 2. All right, and then for B, it's 6 to the right, 0 up. So that the dew point would be 12 to the right, 0 up. So that's 12, 0. Here's the point A8. And then here's the point 2, 4. And then I connect them. Do. And you'll see that, okay, I'm going to draw these lines in, but you don't have to. You can see that from O to A prime, that you basically doubled that length there. From O to C prime, it went 4 like diagonals, and now it goes another 4 diagonals, doubled the length there. And from O to B prime, it was 6, and now the whole thing is 12. And to be honest, what I would expect to see on your work is really just the final image. You don't actually have to draw those little arrows in for the slope and all that. You can just do that in your head. I drew them in there, but you don't have to. Because I just, want to show what I'm doing. All right, yay, do we feel okay about this? All right, I'm gonna do one more. So let's say I want to repeat this process, but instead I'm gonna do a scale factor of 1/2. You do the exact same thing. So for A, again, we find the slope, which we said was up 2 over 1. If I multiply both of those by 1/2, 2 times 1/2 is 1. 1 times 1/2 is 1/2. So now instead of going up 2 over 1, I'm going to go up 1 and then over a halfway. So it'd be like right there. C, we said, was up 4 and then over 4. If you multiply 4 by 1/2, you get 2. So my new C will be up 2 over 2. Be right there. B was 6 over up nothing. If you multiply 6 by 1/2 and 0 by 1/2, then you'll get over 3 up nothing. And then we connect the dots. And then at the end, do you see this? You don't have to draw these lines that I'm doing. They're all on the same ray. They're just different dialects. Doesn't that image look kind of cool? Have you seen these kind of drawing? Like, I swear, Mr. McDaniels does it, I think. Like it's second semester, I usually see people posted these up in the hallway with the little lines for perspective. These are be a big thing at Washburn University because they would send the students out to go do perspective drawing in the hallways. So you would just be walking to your classes and there'd be a bunch of art students at the end of the hall with an easel drawing stuff, and you had to like get out of their way. If you're interested in finding the surface area and volume of this like pyramid-like shape that we just created, you could take calculus. We do that in calculus. We'll draw these and then find the volume, surface area, all that stuff. Isn't that cool? Yes. I like these. I think they always draw little really cool drawings, how they end up looking. All right, does that make sense? Does anybody need any more time to write? Questions? Do you think you could do that? Okay, last thing we're going to do today then is let's have you do that. So here is another triangle. I want you to dilate it by a scale factor of 3. I can tell you that's going to end up being really big. And then once you're done doing that one, dilate it by a scale factor of a third, that one's gonna end up being really itty bitty. And then we'll check your answer in 3 minutes. Might need longer than that, we'll see. And then you'll have the rest of the hour to work. I swear there are some companies that pay millions of dollars for logos that are literally just an image that the dilated up like 2 times. Oh, yeah. I'm actually out of pets. I do have a pet. Will that work? Hi. Also, that first one's right. Good job. Oh, yeah, look at that. No problem. That's right. That's right. Thank you for these legs. And find like the rise of this case for A, just rise. It just goes up 3 no. And then multiply it by the scale factor. So this case goes up 3 over 0, multiplied by 3, go up 9 over 0. So you gotta touch 3 points. And then repeat that for C and for B. Oh, make sure to label A within 5. That is a good dilation. So that is a scale factor. Which is fine. You don't have to take it. You want it to trick. Oh, you change it. You don't have to. That's right. That's right. That's right. Oh, wait, this one, do that one. Right? Do that one. Yes. Yes, that's right. That's good. So same idea, you're gonna multiply both of those by a third. 0 times a third is 0. 3 times a third is. I would. Yeah, well, I mean, you could, but I would, you know, I would just do this, do 3 times 1, 3, and divide by 4. Okay, let's do it. I'm excited. All right, so for A, you should have got that has a rise of 3 and a run of 0. So we multiply that by 3, and we get 9. Rise of 9, run of 0. C was up 3 over 3. Multiply both of those by 3. We get up 9 over 9. B was up nothing over 3. Multiplied by 3 becomes up nothing over 9. And so you get this really big triangle. Notice that it's the same shape as the original. It's still a right triangle. It's just really big. To do this again, I'll do this one in blue. Again, we'll do the same idea, but we'll multiply it by a third instead. So up 3 becomes up 1. Up 3 over 3 becomes up 1 over 1. Because again, a third of 3 is 1. Up nothing over 3 becomes up nothing over 1. Connect those. Yeah, and then again, if you want to make your image look cool, connect those lines together. And look at that. That could be in an art studio. We could just take that right there, put it up at the Mulvane Art Museum. And everyone would just gawk and be like, wow, look at how artistic that art is. That is the most artiest art I've ever seen. Right? Right, Julia? Julia says right. All right, questions about this? Okay, you have 45 minutes to work. That's the end of the lecture. So again, ideally, no one would leave here with homework today.